Welcome to another session of our Kubernetes study group. Today, we're going to cover upgrading Kubernetes infrastructure, so upgrading the versions. The first thing we'll go over will be our upgrade versions and how we can mismatch the different component versions within Kubernetes. And then we'll go through the scenario of actually upgrading a cluster and all the fun stuff. Uh, One thing you should be aware of, it is recommended to upgrade only one minor version at a time. Your minor version is going to be, let me see if I can find an example. Gotta head up here. All right, here we go. So if we look here, 1.28.x, your minor version is going to be your 28. Your 1 is going to be your major version. And X is going to be your patches. So just keep that in mind. When they say upgrading one minor version at a time, you only want to either upgrade this up one, or if you are downgrading, you want to downgrade one at a time, and then kind of just flow to the desired version. All right, back to this picture. Uh, for the different components, the biggest one is going to be your Kube API server because that is what everything talks to. So that everything's going to run off of that as far as the versions. Your controller manager and Kube scheduler, they can be one version before your Kube API server, and your kubelet and kube proxy can be two versions before. Your kubectl can be either one version ahead or one version before. So just you're gonna have to just keep track of these things, or they won't be able to communicate to each other. You'll get some errors if you mismatch your components. Another thing that we're gonna cover once we actually get into the upgrading of the cluster is the Kube API server, control manager, Kube scheduler. All of those core components are going to be upgraded with the Kube ADM tool. This is going to be your cluster management tool. And it'll handle upgrading all of those core components. The kubelet, you will have to use your system management tool to upgrade that, which is going to be your A, apt apt, your DNF, yum, etc. Yeah, same thing with kubectl. Kube proxy is a daemon set, so you'll just upgrade it in the daemon set manifest, your YAML file for your daemon set, and have it roll out to all the different cluster components. Better way to say it, your nodes, all your different nodes. And if you guys remember, your daemon sets are gonna be pods that will be scheduled on every single node within your cluster. So once you update that YAML file, it will go ahead and update all of those pods that are running on all the different nodes. All right. So some things to consider when upgrading worker nodes as well. There's a setting on each worker node called pod eviction timeout. And it pretty much determines how long a pod can be disconnected from the API server before the API server deems it dead. You gotta consider this when you're updating your nodes, because you're gonna have to restart that node, and therefore it's gonna be down. Now, most of the times it'll come back up before the 5 minutes, but in the cases that it does, your master node will consider the pods dead on that node, and therefore will start recreating them on another node or whatever automation that is set up. If they are not part of a deployment set, they're just static pods, not static pods, actually just pods that you just deployed via CLI. They will just be lost. They won't be recreated. They're just gone. So for that reason, it is recommended, really, you have to do this. You have to drain each node before doing the upgrade on it. And we'll go
You
over
have to
that.
drain the whole node?
Yes. And what that does, what draining a node does is just move all of the pods that are on that node to other nodes in the configuration, in the cluster, uh, assuming that there is no taints in place to prevent them from moving to other nodes.
Would you make an empty node for that, or would it have to be
That
recognized?
that is another upgrade strategy that we were not gonna cover today, but I
Oh,
can
okay.
go over real quick. Uh,
No,
so
that's okay.
well, it's
I,
it's fine.
it
We,
just
we
seems
can
extreme to like to drain the whole node and just leave just scattered it all over the place.
no worries. It's a great question, Leslie. Yeah. So that strategy I can go over it pretty quickly. Is instead of you upgrading the nodes that you already have, you just bring in new nodes that are already upgraded. And then you can just specify to in the configuration files for your deployments, your pods, you could just move them all to the new node that is in the new cluster, in the same cluster that's already upgraded, and then just decommission the old node. Does that make sense?
Right, yeah. But I guess you might run into a space issue with that. Is that why you would just move one to other old nodes and then drain that one and then move them to other nodes?
Yeah, that's a good observation. Yeah, if you're creating brand new nodes, you're definitely going to be using a lot more resources. So, yeah, that's a possibility that's what you would consider the fact that you don't want to use those extra resources. If you have space on your other nodes, you can just drain the that node to the other nodes and go about it that way.
Okay.
But it's all
Sorry about the
preferences
question.
and you're good. And I prefer that you ask more questions. A good question like this is yeah, it's all gonna depend on your environment. Is the end answer.
Okay, thank you.
Good question. Thank you. Um so yeah, that's the other thing that you would want to consider is that eviction timeout. Uh, if you're gonna have to do it that way where you are gonna have to live update a node that has pods on it, you can also change that eviction timeout from the 5 minutes to something longer. Evelyn asked, is the reason because the node is damaged, then drain versus replace? Uh, when you drain a node, you're not damaging anything. Trying to think. Yeah, no, you should be fine to use either strategy. It's all just gonna be on your preference and your environment. I mean, yeah, if it's corrupted, then yeah, you won't really have a choice. You just recreate the node. That's correct. That was the question that Evelyn asked. If the node is corrupted, then you would use that strategy. Go ahead and start this lab up. While this thing starts up, we're gonna go over the strategy in upgrading your environment. So when you're upgrading your environment, there is a certain order that you have to go through to upgrade everything the most functional way without having any downtime. Because that's what you want to avoid. If you have an application running in some of the nodes, you don't want users to notice that you were even upgrading it. Uh, so when it comes to that, you would want to, so we went over the kubeadm tool earlier. You want to upgrade that first because that's what's going to upgrade the components of your master node, and is going to upgrade them based on its version, the kubeadm version. So your ADM version has to either match your core infrastructure version or be one ahead. That's something that was not on that chart earlier. On this chart here, your kubeATM in this case would have to be 1.10. If it's 1.10, you can upgrade to the latest or to the latest patch. And if you want to upgrade to the latest minor version, it will have to be 1.11. And then you'll be able to upgrade your Kube API server. And when you use a kubeadm, you won't have to worry about these guys here because they will all get upgraded at the same time. And I'll show you how that works. So yeah, you will upgrade your kubeadm first. Then you will drain the pods. If you have any application pods that are running in your master node, you would want to drain those from the master node. Uh, Reasoning because you're gonna be restarting or upgrading that node is gonna go down. So then after draining the node, you will want to upgrade those core architecture pods via kubeadm. And we can go ahead a little bit ahead here. I can show you what those are. ADM upgrade plan. This is gonna be your components that are gonna get upgraded with using kubeadm. Is gonna be your API server, your control manager, your scheduler, and kube proxy. I did not know that, but yeah, and your etcd server. Although I'll go over that later. Uh, yes. Your kubelet you will have to upgrade by it will not be upgraded via your kubeadm. So because of that, right after you upgrade all of your core components, you want to go ahead and upgrade your kubelet. And realistically, you can do it in either order for these two steps. You can upgrade your kubelet first and then upgrade your core components, which we'll do it that way because I have not done it that way yet. So we'll just see if we get any issues doing it that way. See if we can break anything. And after upgrading your kubelet on your master node, we will go ahead and upgrade all of the kubelets on your worker nodes. The way we're doing it in here is we're SSHing to each worker node and upgrading that way. That is not efficient, so it will be recommended in the actual environment to use a tool like Ansible to do that. Because all it is you can just push a script to upgrade them. It's not very involved as far as upgrading the kubelet. The only thing that you need to be aware of is when upgrading your worker nodes, you have to drain them first. So maybe you set up a group that you're going to drain first, and then you have your inventory file. If you guys remember us going over the inventory files in Ansible, you have your inventory files where you have all of the different uh, nodes separated by groups, and then you push to a specific group that you've already drained, and you just keep going through that order. But you don't wanna upgrade kubelet before you have drained the node. And after that, you can use this kubeadm to confirm that all of the worker nodes are now on the new version. Right now we're on 1.27. As we go through this, as we can see here, the newest version that they have available is 1.28.4. So as we go through this, we want to see this change to 1.28. But yeah, and that'll be it. So we're gonna go ahead and start going. Before actually we do that, does anybody have any questions, anything that I didn't explain enough? All right, let's get started. Hey, what up, Sim? Or did was that Sim joining or did somebody drop? Oh, well, that's Evelyn. Okay. She did say she had to leave at 9. All right, let us explore the environment first. How many nodes do you see in the cluster? Does anybody know how we could find out how many nodes that we have in the cluster? Don't all speak at once. Ah, Sim got it.
To get notes.
Yep, Sim and Leslie both got it. Sim typed it. Okay, get
Some type.
nodes. And here we have our node O1 and our control plane node. So that's going to be 2. And to set things up, how many application do you see hosted on the cluster? Check the number of deployments in the default namespace. And we're going to use the same command, the get command, to get what we have going on over here in the default namespace. And looks like we have one deployment, which is, think about this as one application, and the application has 3 pods running. And of course, they only ask for the default namespace, so we don't have to specify any namespace. On the test, when you take the test, they'll give you a context to work in, which is like they'll tell you to change your default namespace pretty much before pushing any other commands. So you gotta make sure you do that beforehand. Which nodes are the applications hosted on? Okay, so they want us to find out where the nodes are. So for that, we're gonna do k get pods, and we wanna know what nodes they're on. We can get that information with our -o command, which is are gonna be modifying our output and wide. And as you can see here, we're on node O1 and we have one that is on the control plane. So control plane and node O1. We need to take the node O1 out for maintenance. Empty the node of all applications and mark it as unschedulable. Okay, so this is something that I missed when I was doing the earlier explanation. When you drain a pod, it not only moves all of the pods to the next available, pretty much it takes all of the pods off of the node and then marks that node unschedulable. Therefore, when this kube scheduler grabs those pods again to schedule them, it will schedule them on the next available node, which will not include that previous node that you drained them off of because it is not unschedulable. You can also do this without actually evicting the nodes. To do so, you can cardone the node, kubectl cardone node O1. And node O1 is now cardone k describe node, yes, node O1 be in here. Let's do grab. Oh, actually, it's not in there. If there's a way to know if it's cardoned. Oh, here it is. It puts a taint on there that marks it no schedule, unschedulable. That
Okay,
yeah,
that's why I was
yeah.
just gonna ask. Like, how is that different than a tank?
That's exactly what it is, actually.
Okay.
The taint that makes it unschedulable. And If we do the check here, it'll mark this as good. I did not drain it. They want us to drain it, but even like I can just mark it unschedulable without draining it. So when you have a pod or a node that is cordoned or unschedulable, you can of course remove that flag as well. To do so, we just uncordon, cordon and uncordon. Pretty simple, easy to memorize. Node 01 and is now schedulable. Okay, describe. And the taints. Now we have no taints. Do a check. Now we get both X's. All right. So as we remember, we have two nodes here on node 01. They want us to drain it. So let's take a look at what happens when we drain it. Okay, drain node 01. Oh, so this is something that you'll have to add on here. I delete missing policies. Wonder if there's a way to permanently set this. You shouldn't have to type it every time. So I'll look into that another time. Maybe you set up a kind of alias for the command. But yeah, you want to add the ignore daemon sets because if you remember, daemon sets are gonna be on every node, so you cannot delete them. So same command, just add the ignore daemon sets. And it evicts those two pods and marks it. See, it's already cordoned. It's cordoned when I use the command up here. All right, so now that it has been drained, if we do a kget pods, we can see that they are now all in the control plane. Node 1 is empty, and it is cordoned, unschedulable. Any questions on that part?
So the pods are still intact. They're just now on the control plane node.
Correct. It doesn't even, let's see. I'm gonna show you something. Actually, we should be able to see it here. So it does recreate them because you can see the age is 17
Mm.
seconds. It
Okay.
does recreate them. I'm wondering if you have the deployment set as a rolling update, it will probably, I'm assuming it would evict one at a time, depending on what you got how you have your deployment set up. I would hope so.
No, it looks like it just got moved. So
I'm curious now. I'm curious now. Okay, get deployment. Okay, edit deployment apps. Hopefully we have enough resources to do so. So okay, get pods. All right. So now we have 10 of these guys. So now I want to uncordon node 01. When you uncordon, the pods will, that's something that you should also be aware of. The pods won't automatically move over to the new available node. They will have to be killed first, or if there's any kind of restart orchestration setup, and then they will move to get scheduled properly.
mm,
So in this case, what I want to do is drain control plane. Wanna add that. I still have it saved. Nope.
Ignore data
Or
set.
yep. It looks to me like it does all of them at the same time. Uh, Maybe not, because then it also, as you saw, it was getting moving them one at a time. We have Tmux here. Oh, they do. Yes. Pat, what's the command to split this thing? Control B, was it?
Yeah, so you're in TMOX mode already, right?
Yeah.
Yeah, so you do Control B and then Shift. What is it? Shift quotation
Station, yeah.
splits it for you.
There we go. All right. All right. Clear that. Okay, get pods o wad dash w. All right. So now we're watching the pods and shift up. No. What is a control B then?
Control B and up arrow, right? You just move between them like that. Yep.
There we go. I'm still getting the hang of this thing.
Yeah, it's pretty cool.
All right, so down below we're watching the pods, and we should be able to see what exactly what happens. So now we're gonna go ahead and drain. They should all. Oh, we'll have to uncardone. I believe is. No, it's gonna be control node, control plane. And now I wanna drain node nor. So yeah, it looks like it terminates all of them at the same time. There's not really. Can take a closer look at them. Yeah, they were all terminating at the same time, as far as I could tell. Scroll up,
Yeah, that's pretty
Control
efficient.
C. Oh man, there's no way for us to scroll up here. Pat, you know if we can scroll up in Tmux?
You trying to scroll up like I guess you. Oh yeah. That's one thing that's tough about TMOX is to scroll up.
Man,
You can try the less command, see if that cooperates.
get more output if I
Yeah.
zoom out. Oh yeah, I do. Ah,
Oh,
but
Or when you
yeah.
try, or when you're running an output, just use the less command so that way you can go up and down
Mhm.
in your Linux command. Yeah.
seemed like you captured it all though.
Yeah, it does, but I don't like this because you're gonna have downtime this way. These pods, they're light, so it kind of terminates and brings them back up real quick. Your regular pods might not be so light, like you might have a lot more things that need to load up. So they might take 5 minutes, 10 minutes to load up, and there's not really orchestration here set up when you drain. So this is something that you should also consider when you're setting up your deployments, making sure that you have them spread out across the nodes, so you don't have them all in one node, and then you run into an issue where you drain them and you have downtime because you have to drain the node.
Would you do that through the taints?
Yeah, taints, or I think the better way would be with affinities.
Hmm. Okay.
All right, so let's go ahead and exit this. Exit. And let me get us back to regular size. All right, cool beans. So let's continue. That's just something I wanted to find out. But yeah, it looks like it does terminate them all at the same time and then recreates them on the new node. Let's continue. What nodes are the apps on now? They're probably not where they're supposed to be. Okay, get nodes, get pods. -o1. They're on the control plane. They want us to drain. I think they want us to drain node 1 first, so this is where they should be. Okay, cool. Applying patches to node 1. So they're kind of just simulating the upgrade. They just now upgraded node 1, configured the node 1 to be schedulable again. Okay. On Cordone, node 1. How many pods are scheduled on node 1 now? And we kind of just went over this already. They won't actually be recreated on node 1 until something triggers them to be recreated. Once they are triggered to be recreated, then the queue scheduler is the one that's going to schedule them again and is going to see node 1 as an available destination and be able to put them on that node. Why are there no pods on node 1? Yep, here it is. Only when new pods are created, they will be scheduled. Node 1 is not faulty, it is not cordoned, and it was upgraded successfully.
Can we check the version of the node for node 01 now?
Yes, we can. So this is something that you should be aware for the. So Cube ADM is going to be your two. Hold on, I think there's another way you can check it. Yes, your Cube CTL can also find out what version of the node that you're currently on. Since this is going to be your API server node. So Cube CTL version. That's the deprecated command. I think we need a -v. Oh, Cube CTL version -- short. There we go. So this will tell us the server is gonna be your API server, 1.27, and the client is gonna be your Cube CTL version. So don't forget that it also has to align with the specification. It can be one ahead or one before. So make sure you upgrade or downgrade your kubectl as well. But to check, you can do kube ADM upgrade plan. And the way Kubernetes checks a node's version is by kubelet. So you can either check it by going in here and we can see that they are all still 1.27. There's only two nodes, so they're both 1.27. Or you can go on each node and check the kubelet version that's installed on that node.
So it's trying to get to 0.8 and we're on 0.0 right now. Okay.
The reason why the target is set to 1.27.8 is because our kube ADM version is 1.27.0. So it will only go to the latest patch. The 0.8 is the latest patch in 1.27. If there's any patches in between, we can do those as well. But to get to 1.28, we will have to upgrade the Cube ADM version.
Okay. That's what I was wondering. Okay.
And I believe we'll get into that in these instructions. So why are the pods placed on control plane node? That's because control plane does not have any taints. All right, time traveling. Next maintenance window. Oh, that's a freebie question. We need to carry out maintenance activity on node O1 again. Try draining the node again using the same command. And they help us out. Oh, did they move them there? Let's take a look. Okay, get pods. Did they delete all my extra pods too? No, they're still here. Drain node O1. Oh, okay. I see what they're doing. So they want us to test something. So we're gonna go ahead and run the command that they want us to run. And let's see what happens. Error, unable to drain node 1 due to error, cannot delete, pause, declare no controller. It's forced to override. Node 1 is the issue here. Why isn't, that did not work? No. So why did it not work? Thing I would do first is I would check node 1, which is not part of the, I would check, I would get an explanation, get a describe on the pod. The, oh. Sure. All right, so here's our pod. Don't see anything that would prevent it from getting scheduled on somewhere else. Here's some tolerations.
The toleration.
That just means it can be scheduled. It should not make it unschedulable.
Is it because it was a Cardone?
No, because we have other pods. We know that he has not been cardoned. That's not one of the options. But yeah, you obviously you want to check the k-describe nodes. That actually would probably be the next thing that I would check. K-describe nodes, because we're trying to get it to control plane. And I would grab 14th. We got none. But the next thing is you should be aware of, I mentioned it earlier a little bit, is if it's a pod that's just scheduled by itself on a node, it's not part of a deployment, it's not part of a replica set, we cannot drain it. You'd have to recreate that pod on another node, specify for it to be recreated on another node. So we would have then that what I would check for that is I would get all replica sets. Okay, get replica. And blue is the only replica set here. We don't have a replica set for HR. So therefore, we're not able to get it to be rescheduled. Because if you remember, the way that works, the drain command works, is it just deletes that pod and cardones the node. It doesn't actually tell the system to recreate it. The system is already set up to recreate pods that are part of replica sets if it sees that the pod died. But that's not part of the drain command. So therefore, if you were to use the drain command and destroy that pod, the queue scheduler, it doesn't see a replica set for it. It would not know to recreate that pod. So in this case, the reason why it did not work is it's not part of a replica set. Does that make sense?
Mm-hmm.
Perfect. I, what is the name of the pod hosted on Node 1 that is not part of Alexa? We already saw that. That's the HR app. What would happen to HR app if Node 1 is drained forcefully? Yeah, it will be lost forever. It's gone. We don't want that. Okay. HR app is now in deployment. Let's just make sure that they're not lying to us. I don't know why they would, but there it is. HR app. Is a critical app. We do not want it to be removed. We do not want to schedule any more pods on Node 1. Mark Node 1 as unschedulables so that new pods schedule schedulable so that no new pods are scheduled on this node. Make sure that HR app is not affected. On Node 1. Interesting. So in this case, because they want Node 1 unschedulable, but not actually they're not actually asking us to drain the node. We do not want it to remove. Yep. So in this case, we'll just want to use the just cordon that node. Okay, cordon node 1. So that should fit the criteria. All right, cool. In this case, yeah, we just marked it unschedulable, but the pod should still be there. Get pods. Our HR app is still running, and it's on Node 1. All right, that's it for this lab. As far as this is the lab that we went over all the how to drain and how to mark nodes unschedulable. And yeah, we haven't yet gone over actually upgrading the infrastructure. I think that's gonna be the next one. So do we have any questions as far as scheduling of the pods when during the upgrade process? Cool beans. We'll go ahead and jump on to the next one. Dun, 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 dun. All right. This lab is gonna test your skills in upgrading clusters. We have production cluster application running on it. Let's explore the setup. What is the current version of your cluster? For that, I will use the trusty cube ADM. Upgrade plan. Looks like we are on 1.26. If you can see it up here, cluster version 1.26. Right here for you guys. How many nodes are part of this cluster? Now we can't do a cube get nodes, but you can also see right here we have two kubelets, so there's two nodes available. And just to confirm, k get nodes, where they are. How many nodes can host workloads in this cluster? Describe.
This is a capacity thing.
Uh, so they specify here as far as taints go. But yeah,
Oh,
of course,
okay.
the capacity would also play a factor if they can host nodes or pods or not. So let's do describe nodes, node 1 and control plane. We can do both of them at the same time. Or we can grab, since they ask specifically for taints, both of them have no taints, so both of them should be able to host applications. So 2. How many applications are hosted on this cluster? On the cluster. Count the number of deployments in the default namespace. Okay, get deployments. There's only one. What nodes are the pods hosted on? How will we find? Do you guys remember how we would find out what nodes that the pods are on?
Right. Oh,
What was that? We can do a get command on the pods because they're trying to find out what nodes the pods are on, and the we can add the option for our output to be wide, which gives us more information, and that will tell us what nodes each pod is scheduled on. So as we can see here for the nodes, we have them on node O1 and control plane. So we can go ahead and yeah, do that. You are tasked to upgrade the cluster. Users accessing the application must not be impacted. You cannot provision new VMs. What strategy would you use to upgrade the cluster? And we would not want to upgrade all nodes at once because that would leave us with downtime for the users, so that would not match this specifications that users cannot be impacted. And they say that users will be impacted since there is only one worker node, but both are usable as worker nodes, even the master node. So that is not the right answer. Add new nodes with newer version while taking down existing nodes. This would not work because they specifically said that we cannot provision new
I
VMs.
can't provision it.
Yep. So the only option is going to be upgrade one node at a time while moving the workloads to the other. What is the latest stable version of Kubernetes as of today? As we can see, our kubeadm will tell us that the remote version here is going to be 1.28.4. And there, I think this right here is just not updated, but that is the right answer. What is the latest version available for an upgrade with the current version of kubeadm tool installed? The current one that we have installed is 1.26. That's our kubeadm version. Therefore, you cannot upgrade to a version that's exceeding the kubeadm itself. So it's gonna be 1.26, the latest being 1.26.11. We will be upgrading the control plane node first. Drain the control plane off workloads and mark it unschedulable. So this is where we get into the actual upgrading of all of these components. And I'll just just real quick, I'll go over the order is to upgrade your kubeadm, then upgrade your core components, which is going to be your scheduler, proxy, these guys right here. It's a SCD, scheduler, control manager. After that, you're going to upgrade your kubelet, and after upgrading all of the master node components, we will go ahead and upgrade all of the worker nodes, which is just going to be upgrading the kubelet on those worker nodes. All right.
So are you upgrading all the different components first? Okay.
Yeah, the master node components first.
Mhm.
And just remember this, the thing with this chart, if you follow that structure, you will never run into any issues with this chart, because these all will get upgraded at the same time, and then you will upgrade this one right after. So it's never going to be more than one version before. Say
Okay.
the kubectl is something that you might forget, of course, because it's kind of separate. It's its own utility. But yeah, just remember, make sure that I would just make sure that all of your versions match on everything. So then you don't even have to worry about any of this. I don't know if there's specific scenarios. That's something I might learn later. There's specific scenarios where you might not want to upgrade a certain component, but I'm not currently aware of that. All right. Oh, something also to be aware of. My understanding is the control manager scheduler, they have to be the same version. Same thing with the kubelet and kube proxy, and everything else is independent. And if you're using your kubeadm, of course, it's all gonna get upgraded at the same time, so it won't even matter. All right. So let's go ahead and jump into it. They want us to drain the control plane first before we even upgrade anything. So let's go ahead and drain. Cage, drain, control plane. Don't forget your ignore. All right, it has been drained. And they want us to upgrade it to 1.27. And it telling us that apt-get is the version that we have, the package manager that we have on this node. So first thing we want to do is one thing. If you notice this, you go to install the version. Let's back up to install the latest version of kubeadm. That's where I would start, is installing the latest version of kubeadm. We would run the command because you don't want to actually get the latest version. We want to get 1.27 version. This is a very specific version. Because if you just do apt install, in fact, we can do that right now and we'll see how it works. Apt install. Well, yeah. Let's see what happens. kubeadm. Yes. So as you can see here, it installed 1.28. If you do a cube ADM plan upgrade plan. So you know this version of kubeadm was supposed deploying to a cluster version 1.27. So here's how you can also downgrade it, or this is really you're installing a specific version of it. You're gonna do the same command apt install kubeadm. If you have yum dnf, whatever package manager, it's all the same. You just change the package manager at the front. Apt install kubeadm. You're gonna do an equals. 1.27.0-00. So that's gonna give you all of your minor versions 27. Or yeah. So let's do that. Yes. As you can see here, it'll actually downgrade it back down to 1.27. So now if we do a KubeADM upgrade plan, much better. See, our KubeADM is now version 1.27.0, Rust is 1.26, and now so this we can still upgrade to 1.26.11, or the way this works, you would have to actually upgrade to 1.27.0 first before you can go to 1.27.8. Because I have tried that and it gave me an error. All right, so our KubeADM is now in place. Next up, well, let's follow what they're telling us to do. To upgrade the KubeADM tool now ready. Then control plane components. Actually, that's exactly what they're telling us to do. So next up, we want to go ahead and upgrade those Q components. So you can actually just copy the command here. And yeah, this is what I had done. And I believe it gave me an error. Yeah. Higher than the KubeADM version 1.27.0. Oh, okay, I see why. I'd have to upgrade the KubeADM to 1.27.8. All right, but we could just put this to .0, and that should work. Yes. Any questions so far? Remember, this process is a bit lengthy.
As I say, it's a lot of stuff in this.
Yeah.
But after the drain, you just get rid of the components. I mean, upgrade the components and then bring them back.
With the drain, so the drain is only meant for application pods. It doesn't actually remove the components, because the components,
Oh,
if you remember, they're static pods.
hmm
See if we have it somewhere. Yes. Oh, yeah, because we only read the default namespace, so we're not going to see those components. But they are static pods that are deployed to the kube system namespace. They won't be affected by the drain. As far as the API, because the API server is the one that's doing the drain. The API server only has read access to the static pods. The kubelet is the one that creates those pods. It has write access, but you won't be able to affect those other than read and see those pods with your kubectl command, because if you remember the kubectl commands, they talk to the API server.
Oh,
And the API, as I said earlier, API server does not have write permissions to static pods.
okay.
Does that make sense? I know it's a bit much.
No, I get it.
Okay.
We just have to upgrade them separately and do what we want to do with the stuff we drain.
Yep. Give me 1 second. Pat, were you asking a question?
Yeah, my question is around, maybe you explained that before already. My apologies, but how often it looks, to me, it looks like. So my question is, how often is this type of upgrade performed? I know, and what's the level of impact, right? what I mean is, if you have applications running, is this disruptive? Is this smooth? Are you, like what is the best practice here? That's really what I'm
Yeah.
asking. Yeah.
No, yeah, good question. Uh, I don't work in production, so I don't know how often the upgrades are done, as far as like best practices. Um, I'm assuming it's the same as when you're upgrading your in Windows environment, you're gonna go ahead, upgrade comes out, you're gonna go ahead and research that upgrade, see what's changed, and see if it's gonna break anything when you actually upgrade to it. You're gonna probably do a testing, like have a testing environment to test that upgrade, and then push it out to the actual application. As far as a disruption to the customer or to whoever is using the application, this whole process, the way we're doing it, is set up that they don't even notice the upgrade. There's no downtime for the end user because the application is always going to be running on a separate node. Like right now, we're upgrading this cluster. It's a cluster of two, but just think about it in a like it's just in a scaled up setting. Uh, let's see, what was that command? All of the applications are still running on Node 1 while we're upgrading the control plane. And the master for these applications to be running, the master node is not necessary because the networking is done on the pod themselves, at the node, on each node via kube proxy. So people will still have access to them even if the master node comes down. Now, the one thing you have to be aware of while the master node is down, unless you have like some kind of HA setup, a high availability setup where you have two master nodes, you're not able to send any commands, like any orchestration. All of the orchestration is not working. So if right now the pods were to crash, they would not get recreated. So that's just something that you want to be aware of. So your maintenance window, you won't want to drag it out because over time it will affect your application environment infrastructure. But does that answer your question?
Yeah, that's pretty good. Yeah, because my concern was, so that makes sense. Yeah, that it wouldn't impact the application. It's that it would perform that upgrade without any user seeing it. Because I was worried that maybe you have to come up with another cluster, test the new upgrade. Once it's happy, then go over to the running cluster. But it looks like in this case you really don't have to. So that's pretty cool.
Yeah. I mean, I would recommend that you still test it, but I wouldn't like you just you spin up your own environment, a whole separate environment, and you test it on the new upgraded version of your cluster there,
Cool.
then push it out to the live environment. And we'll go over that when we get into next week. Actually, we're gonna do the application lifecycle. And that's gonna have all of the ways that you keep the application always running. Uh, we'll go over those deployment strategies.
Cool. Thank you, man.
Yeah, no problem. All right, so once the core components are now upgraded, we can just double check that here. Cube ADM upgrade plan. And as we can see, all of our components are now 127. etcd did not get touched because it has seen something in here. Pretty much your upgraded CD could not find officially supported version of etcd Kubernetes 1.27. So he tries to upgrade the etcd to 1.27, but etcd is a separate product. It's not actually part of the cluster. It's not part of I almost want to say it's not part of Kubernetes. but I don't want to misspeak, so I won't. Don't take that word for word. But it's a whole separate project that was added to Kubernetes. So it has a separate version. So you have to upgrade it by itself. Yeah, that's the gist of it. You have to do a separate upgrade for the etcd. Well, everything else is at the appropriate level, I would say, except for our kubelets. That's what we're gonna handle next. So to upgrade the kubelets, let's go ahead. We're just gonna install the newest version of the kubelet. Okay, install. Oh, not the latest, sorry. You're gonna install the 1.27 version. Kubelet 1.27.0-00-yes. Apt. Okay. Okay, yep. So it did install the 1.27. And the thing I wanted to happen, which I thought would happen, is it would in fact find the package. And just remember, if you don't find the package, just go ahead and do an upgrade, not upgrade, apt update, and just to get an updated list of our packages. But yeah, it looks like in this case we did not hit that stall, so we are now all good to go. 1.27. If we do another KubeADM upgrade plan, as we oh forgot one part. Well, kubelet, it is a system CTL. It's a system component, so you got to make sure that you start it. And it did tell us that at the end of the command, at the end of the upgrade, that it's not running. The new kubelet service is not running, the 1.27. Oh, let's do systemctl, restart, kubelet service. That should put us at the new version. All right, perfect. So now you can see one kubelet is now 1.27. That's the one here on the master node. So that should be all the control plane components. Any questions on the control plane stuff? All right. Go ahead and jump in it. We will now want to uncordon our control plane. And we should be good to go on that one. Next, we want to upgrade the worker nodes. So let's go ahead. Drain node 1. All right. And upgrade the worker node to 1.27. So for that, we're gonna be jumping over to the worker node. SSH to node 1. And same thing, we're just gonna upgrade our kubelet.
And you didn't have to drain this first or anything because you knew it was already empty.
We did have to drain it. That's what we did right
Oh,
here.
right there.
Yep.
Okay.
Yeah, you always want to drain it because we are going to be restarting the kubelet on the server.
And
Which
when you restart that service, it makes it reset.
the
Okay.
kubelet is going to be your node controller. Is
hmm
if you restart it while you have pods on that server, well,
Oh, you'll stop the pod.
it's an assumption. We can test it actually after this. My assumption is that the API server will not know that these pods exist.
Mm.
And you'll just have pods running with that are gonna be just hogging up your resources. They're gonna be disconnected from your API server. But we can test that. So let's go ahead and up to install. Okay, so this is where. So we couldn't find that version, so just go ahead and do apt update to update
Okay.
the available packages. All right, perfect. Now we should be able to do this. All right, with that, we are good to go. Don't forget to restart your service. And that's it. So now if we do a upgrade plan, all of our nodes are now on 1.27. So now, okay, let's go ahead and check worker node ready. Oh, we didn't actually on Cordona, so it wasn't ready, but on Cordon. That's it. All right, so while we still have this lab, let's go ahead and test that theory. Okay, get odds dash wide. Control plane. Okay, on Cordon. All right, so now if we do get pause, they're all on node 01. Let's SSH over to node 01. And this is what testing environments are for, so we can test these things before having them happen in production.
Fingers crossed.
Let's go ahead and we're just gonna restart kubelet service. What happens? Actually, what I want to do is apt install. I'll just install the 1.28 version. Then we'll go back to 1.27. Actually, let's refer to this chart. Our kubelet can be 2 behind. Can we do 1.25? Okay. And we want to restart. Okay, so now okay,
Yeah.
get
Now we got to see about the node. Yeah, the pod.
we are still there. I showed the Kubernetes at 1.25. What happens when we try to
Why do they separate the different? Okay.
control planes are Cardone right now? So let's do okay. Let's work with a deployment. Okay, edit deployment blue, and we're gonna add 5 more here. Make it 10. Okay. That's 10, right? 1, 2, 3, 1, 2, 3, 1, 2, 3. So it doesn't seem to have an issue as far
Hmm.
as I can see. But it is best practice. I like this is we're not probably not having everything. There's some things missing here that we may not be aware of. Best practice is to move all of the pods off of that node prior to upgrading it.
Mm-hmm. It sounds like
But
the wise thing to do.
in this case, yes, we were able to upgrade it without actually draining the node with no issues.
This is practice. We don't want to do this in the real world.
Yeah, yeah, of course that. But with that, that concludes all of our labs for today. Let's see here. Yeah, we'll jump into this. We're actually gonna jump back to the application lifecycle. I wanted to do this before the application lifecycle, and then we'll come back to the backups and stuff. Any questions as far as upgrading the system for Kubernetes? I must have done an amazing job.
Yes, you did a great job. Thank you.
Yes, indeed.
All right, with that, we'll conclude today's session. As always, if you are watching this on the replay and you find this information valuable, just like and subscribe. And if you are looking to join our study group, just shoot me a message on LinkedIn or leave a comment below. Thank you for watching, and I'll see you guys on the next one.